Good day and welcome. In this video, I will try to assist you to prepare for paper 2 that you will have to rewrite. I will look in this chapter specifically to geometry and also proportionality. When we look at proportionality in triangles, we will firstly look at the ratios and we will look at theorem 1. When we look at similarity in triangles, we will look at theorem 2 and theorem 3. And then also theorem of Pythagoras, how to prove this theorem using the corollaries from theorem 4. When we work with congruency, the following should be imprinted in our toolkit already. Firstly, the different cases of congruency. First one, side, side, side. If three sides are equal to each other, then those two triangles are congruent. Then we have angle, angle, side. And here we have two angles and an excluded side. Then we have side, side, angle, but the angle must be included, meaning between the two sides. Then right angle, hypotenuse and side. If we have the right angle, the hypotenuse and one of the sides that are equal, then we will have also another case of congruency. When we work with similarity, if I have as much as two angles being equal to each other, the third angle automatically will also be equal to the third angle of the other triangle. Therefore, when we work with similarity, angle, angle, angle refers to similarity. When triangles are congruent, they are also similar. And therefore, I can also conclude that side, side, side also renders similar triangles. The biggest concern that I have when I work with this particular topic is that learners tend not to have the basic knowledge to assist them to prepare for this topic of geometry. For example, properties of your special quadrilaterals, and these include the parallelogram, the rectangle, the rhombus, the square, and the kite. We should have a sound knowledge of the properties of these different shapes. So, first things first, when we work with the parallelogram, we need to understand that both pairs of opposite sides are parallel to each other. Both pairs of opposite sides are also equal to each other. And both pairs of opposite angles are equal to each other. We should know that the diagonals bisect each other, meaning that this length is equal to this length, and this length equals to that length. So, the midpoint of this line segment and the midpoint of this line segment will meet in the same point. Often on the Cartesian plane, when I have to prove that something is a parallelogram, I merely have to do that. Prove that the center of both line segments meet in the same place. When I work with a rectangle, all the properties of a parallelogram applies to the rectangle with the exception that the angles are 90 degrees. Also, with a rectangle, the diagonals bisect each other the same lengths. So, this length and that length will be the same. I need to also understand that the difference here is that this diagonal is exactly the same length as that diagonal for a rectangle compared to when I work with a parallelogram. When I work with a rhombus, all the properties of a parallelogram once again applies, but I need to understand that the opposite sides, all sides, are equal. The diagonals bisect each other at 90 degrees, but remember, the one side will be longer than the other side. So the midpoints, although they meet in the same place, they are not necessarily the same length. When I work with the diagonals, I also notice that the diagonals bisect the interior angles, and this applies on both sides. Now, this brings me now to a square. Remember, the rhombus had all the properties of a parallelogram plus the other three. Now we get to a square. Square has got all the properties of a rhombus. The difference is that the interior angles are all 90 degrees and the diagonals are equal in length. Diagonals will bisect at 90 degrees and they also bisect each other. They will bisect the angles. So I will have 45, 45, 45, 45, 45, 45, and 45 degrees. All the sides are equal. Now it brings me to the properties of a cut. Two pairs of adjacent sides. That one as well as this pair of adjacent sides are equal. Now the diagonal between the two adjacent sides, this one, bisect the other diagonal. Also, the diagonals meet at 90 degrees. We also notice that one pair of opposite angles are equal. Diagonals between the equal sides bisect the interior angle. So this diagonal bisects that angle as well as that angle. The diagonals we mentioned bisect each other at 90 degrees. The last shape on our list is the trapezium. There's only one property that a trapezium has. One pair of opposite sides are parallel to each other. Generally, we are asked to prove that a quadrilateral is a parallelogram. How do we prove this? We can prove this by doing any one of the following. Prove that both pairs of opposite sides are parallel. Prove that both pairs of opposite sides are equal. Prove that both pairs of opposite angles are equal. Or prove that the diagonals bisect each other. How do we prove that a parallelogram is a rhombus? There's two things I could do. Prove that the diagonals bisect each other at 90 degrees, or prove that any pair of adjacent sides are equal in length. This brings us to the midpoint. This theorem states the line segment joining the midpoints of two sides of a triangle is parallel to the third side of the other side of the triangle and is half the length of that side. We express it in symbols. If AD is equal to BD and AE is equal to EC, then DE is parallel to BC and DE is half of BC. When we work with the converse of the midpoint theorem, then we say that if a line is drawn from the midpoint of one side of the triangle and is parallel to the other side, then that line bisects the other side of the triangle. So, how do we state this thing? This line will also be half of the second side of the triangle that it is parallel to. So if AD is equal to DB and DE is parallel to BC, then DE bisects AC into AE and EC being equal to each other, and that DE is half of BC. Let's briefly look at the concept of proportionality when we recap this. So if I have line segment AB to BC, I will have a 6:4 ratio, and simplified it will give me a 3:2. And I say I've got DE to EF. Once again, this can be simplified as a 9:6, and 3 goes in 9 3 times, and 3 goes in 6 twice. So also a 3:2 ratio. Although AB to BC is equal to DE to EF, it does not mean that AB is equal to DE. Likewise, it does not mean that AC is equal to DF. Nor does it mean that BC is equal to EF. It's just in the same proportion. Thank you for watching this video. I trust that the explanation and introduction to geometry served you well. And if there's any questions or you need assistance, feel free to get in touch with me. My contact details are listed. Goodbye.